Hi, this is Leetcode question, increment submatrices by 1, and this is the second question from weekly contest number 328. In this question we are given a matrix of dimension n by n. In this example it's n equal 3, so we have 3 rows, 0, 1, 2, and 3 columns, 0, 1, and 2, and all the elements on the matrix are initially set to 0. We also given an array of queries. For every query we have the top left corner. So for the first query we have top left corner 1 1 1 1 is here, this cell, and the bottom right corner, which is 2 2 2 2 is this cell, and all the cells covered by these corners. So we have this rectangle that this is the top left corner, and this is the right bottom corners. All the cells in between must be increased by 1. So 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 1 is 1. For the second query we have the top left corner 0 0, which is here, and the bottom right corner is 1 1, which is this cell. So all the cells in this rectangle must be increased by 1. So we have 0 plus 1 1, 0 plus 1 1, 0 plus 1 1. Here we have 1 from the first query, so 1 plus 1 is 2. And we finished all the queries, so our matrix becomes 1 1 0. Then we have 1 2 1 0 1 1. So this is how the matrix looks after handling all the queries, and this is what we should return. And the time complexity for this is if we have the number of queries equal q multiplied by n multiplied by n. So we need to find a better or efficient solution, and to do that, imagine instead of having 2D matrix, let's say we have 1D array which has one row and multiple columns. For this example we have 1 2 3 4 5 6 columns, and we need to increase by 1 all the cells between index 1 and 3 for the first query. So 1 is here and the 3 is here. So all of these cells must be increased by 1. So 0 plus 1 is 1, and 0 plus 1 is 1, 0 plus 1 is 1. This is for the first query. For the second query it's from 2 to 4. So this is 2 to 4. So 1 plus 1 is 2, 1 plus 1 is 2, and 0 plus 1 is 1. Then for the last query from 2 to 5, this is 2 plus 1 is 3, 2 plus 1 is 3, 1 plus 1 is 2, and 0 plus 1 is 1, and after handling all the queries, the array becomes 0, 1, 3, 3, 2, 1. So this will be our answer, but again we did it in inefficient way. Now instead of doing that, what we will do for every query, so for this query 1 to 3, what we will do is we increase the cell at 1 by 1. So 0 plus 1 is 1, and the index at 3 plus 1, so this is 3 plus 1, we decrease it by 1, 0, so 3 plus 1 is 4, so at index 4 become 0 minus 1 minus 1, and this means that from 1 up to 4 we have 1 plus 0 1, 1 plus 0 is 1, 1 plus minus 1 is 0. So it's a different way of representation, and this is called scanline algorithm. Now we move to the next query. Again, at index 2, 0, 1, 2, we increase it by 1, so 0 plus 1 is 1, and at index 4 plus 1, which is 5, we decrease subtract 1, so at 5 it become minus 1. Now for the last query, at index 2 we increase it by 1, so 1 plus 1 is 2. Then at index 5 plus 1, which is 6, but 6 is out of the boundaries of this array, so no need to subtract minus 1. Now we will loop over all the elements from on this array, and we do like prefix sum. So we start at index 0, 0, the value is 0. Then here we have 1, and 1 plus the previous value is 0, so this is 1. Then at index 2 is 2, so 2 plus the last value, which is 1, 2 plus 1 is 3. Then here we have 0, 0 plus the last value, which is 3, is 3. Then we have minus 1 plus 3, which is 2. Then we have minus 1 plus 2, which is 1, and this is the same answer we get here. And we will do the same for the 2D matrix. So for every queries we will handle all the rows, and we will assign 1 and subtract 1 for the edges. So for the first query we have rows from 1 to 2, so we need to handle rows from 1 to 2, and for every row we need to add 1 for this edge. So at 1, so let's start from the first row. The first row at 1 here, we will increase it by 1, so this become 1. And at index 2 plus 1, the same what we did in the 1D array, 2 plus 1 is 3, so 3 is outside the matrix, no need to do anything. Then we move to the next query. or sorry, we need to move to the next row again. At column 1 we increase it by 1, and at column 2 plus 1 is 3, which is outside the boundary of the matrix. Will not do anything. Now for the second query, we have from rows 0 until rows 1. So we need to handle this row 0, then this row 1. So we start for row 0. We have at column 0, we increase it by 1. So 0 plus 1 is 1. And at column 1 plus 1, which is 2, we need to subtract 1. So 0 minus 1 is minus 1. Then we move to the next row. So at index 0, we will increase it by 1. 0 plus 1 is 1. And at index 2 again, which is 1 plus 1, we subtract it by 1, which is minus 1. Now we're done from all the queries, and that's cost us Q, the number of queries, multiplied by the number of rows. Now we need to do the same, do prefix sums for every row in the matrix. So we will loop over every row. So for the first row, we have this value 1. Then the second value is 0. 0 plus the previous value 1. So this become 1, and we have here 1. So 1, 1. Then we have minus 1. Minus 1 plus the previous value 1 becomes 0. Then for the next row, we have this value 1 stay as is, as it's the first cell. Then we move to this cell. We have 1. 1 plus the last value 1 is 2. Then we have minus 1 plus 2, which is 1. Then we move to the last row. We have initial value 0. Then 1 plus previous value 0 is 1. Then we have 0 plus previous value 1, which is 1. And so our final matrix will be 1, 1, 0, and 1, 2, 1, and 0, 1, 1. And this is indeed our answer for this example. And this loop cost us the number of rows, which is n, multiplied by the number of columns, which is n. So the total complexity will be q multiplied by n plus n multiplied by n, and this is instead of q multiplied by n multiplied by n. So this solution is much faster. So let's look into the code here. So in this this will be our final answer, the 2D vector. And here we loop over all the queries, and we increase a 1 at the edge, or at the column value, which is q of 1, and we subtract 1 for q of 3 plus 1. And here we do prefix sum by looping over all the rows and all the column.